Okay guys, I just got my hands on exam 2. So let's have a crack at the multiple choice. Hopefully I won't make any mistakes. The first one, the period of a tan graph is pi on n, which in this case is pi on 2, which is 2. Okay, this one here, these two graphs are identical over the same domain. We know if we've got a plus here, well, that can be log e of 2x times x, which is log e of 2x squared, which is that there. Of course, if x is greater than 0, this will work, but it'll also work for negative values, but over the domain greater than or equal to 0, it's going to work. Okay, a box contains many colored glass beads. A random sample of 48 beads is selected and found the proportion of blue colored beads in the sample is 0.125. So if we do 0.125 times 48, there's 6 out of 48 that contain whatever it was that they wanted. We want to do a 1 prop z. Our confidence level is 95%. We know, do we put 0.95 there? I think it's 0.95. 6 out of 48, 0.031 and 0.218. So, is that it? 0.2186, yep. Perfect. Okay, here, the maximum value of this function, x minus 2 e to the x from 0 to 2. So if you use your CAS, x minus 2 times e to the x, f max between 0 and 2, maximum value is 0 when x equals 2. Okay, which of these following 4 functional relations, the number of these functional relations that are satisfied by this equation? So f of x equals x. Okay, so remember it's a line that looks like that. So if you reflect it in the y-axis, it's not the same as the original function. If you reflect it in the x-axis and in the y-axis, it is the same. If you reflect it in the x-axis, it's not the same. If you square the whole function, or if you replace x with x squared, so here, if I had f of x as x, if I square that, is that equal to f of x squared? So that would become x squared, and that would be x squared. I think that's right. I'm just having a mental blank. So what we can do is use the judge function in our calculator. So x, define it, and then say judge f of x all squared equals f of x squared. True. Okay, so we know it's twice there and there. I just had a mental blank. I wanted to make sure it was right. Probably winning a game is 0.25. The probably winning a game is independent of anything. Ben plays 10 games, probably win exactly 4 games. So it's binomial. We want to get exactly 4 games out of 10, and the probability of success is 0.25, 0.1460. Exactly 4 games. Independent means that it's binomial. Okay, the graph of the tangent that passes through the origin, the value of a is x cubed minus ax squared. A times x squared is plus 1. Find the equation of the tangent at the point x equals 1. And we know it's got to go through the origin. So it equals 0 when x equals 0. What? y equals 5x minus 2, I must have a defined. Okay, so get rid of that. We know that's equal to 0 when x is equal to 0. So we solve for a. So we get a as 1. This one here says the graph of the derivative. Now, if you've got an undefined point on the graph, you know the derivative can't exist, so it can't be that. Could possibly be that. They've all got vertical asymptotes. If you look at the gradient here, it's always positive. It starts really steep, and then it's getting lower. Can't be there. There's 0. It's got to be above the axis. Can't be here because it doesn't exist on the left, so the only one it can be is E. Okay, if h is the composite function of that, then the range of h is, it's probably easiest just to do f of g of x. So x plus 2 squared minus 4 between -5 and 1. X plus 2 squared minus 4. X plus 2 squared minus 4 between -5 and 1. Okay, so the lowest value is -4. The maximum value, bloody hell, is at 5. And we know at -5 it's defined, so -4 to 5, because it's defined on that endpoint. Okay, for these to be defined on their maximal domain, we've got to find the maximal domain of that. So x is greater than or equal to -2, and the maximal domain of that is greater than or equal to 0. -2x is greater than or equal to -1. X is less than or equal to 1/2. So it's got to be between -2 and 1/2 inclusive, because you can square root 0. Okay, so from 0 to a is k. So we know we can say this is 3, 0 to a, f of x dx, plus 0 to a of 2 dx. We know this is 3k. We know this is 2x between a and 0, which is 3k plus 2a. All looks correct to me. 3k plus 2a, yep. For a certain species of bird, the proportion of birds with a crest, where'd it go, is known to be 3/5. Let P be the random proportion of birds with crest in sample size n for this specific bird. The small sample size for which the standard deviation of P is less than 0.08. Okay, so the standard deviation, is P, 1 minus P, on N. That has to be less than 0.08. Okay, so 3/5, 2/5, square root of 3/5. Go back. Times 2/5 over x. If I let it equal 0.08, we get 37.5. So if it's got to be less, the standard deviation gets smaller as you increase the number, so it's got to be 38. So for example, if I did this and I said 38, it's going to be less than 0.08. But if I said 37, it's going to be greater, and we want it to be less than, so you've got to round up. Okay, the value in dollar after n months is multiplied by that function. The average rate of change over 12 months is. Okay, so if I put 0 into that, I get 2,500. If I put 12 into it, 2500 times 1.004, is it 3 zeros or 2? To the power of 12. Okay, we get that minus 2,500 divided by 12, 10.22222 is closest to $10. The average in the first 12 months is, yeah, $10.20 per month. That makes sense? Okay, the value of k, for which the average value of that over that interval is equal to the average value of sine x over that interval. Sine between 0 and pi is 0. 0. Pi. Oh no, it's not 0. What am I thinking? It's going to be a half, maybe? Okay, let's just do it. Sine x, the integral from 0 to pi dx. And out the front we've got 1 divided by pi, which is the interval, which is 2 on pi. We know in this case we want to have 1 on pi between 0 and pi of cos of k times x dx equals that. We want to solve for k, negative a half or a half. So it's not negative. And that's because when you're reflected in the y-axis, it's probably similar. So here, if we try this, and we said 1/2, we get 2 on pi, so we know that's correct. 4 fair coins tossed at the same time. The outcome for each coin is independent of the outcome for any other coin. Probably there is an equal number of heads and tails. So we could only have 2 heads and 2 tails. Probably there's at least 1 head. Okay. So let's say x is a binomial random variable. We've got 4 coins, and there's a half a chance of getting a head. The probability that we get the same number of, like an even number of heads and tails is when x equals 2, because I get 2 heads, so I've got to get 2 tails. I couldn't get 0, 0, or 4, 0. And that's over the probability that x is greater than or equal to 1. So we say 2 heads out of 4, and there's a half chance of getting a head. And then, I want to find greater than or equal to 1. What have I just done then? So 1 to 4 out of 4 and a half a chance. Okay, so that divided by that is 2/5. Now they could be in any order, that's why I used binom CDF PDF. Okay, here cos of x is 3/5. So if cos of x is 3/5, if we draw a triangle, cos is 3/5, so sine of x, and x is in the fourth quadrant. So I know sine of x is negative 4/5. It's 4/5, but because it's in the fourth quadrant, we know it's negative. Y, because we're trying to find sine of x, cos of y, if we solve sine of y, we've got to square it the right-hand side, and we get 5/13. So what? Cos is 5/13, so the other side's got to be 12, and that's cos of y. So sine of y, Sine of y is 5 over 13. So cos of y is 12 over 13. And it's in a quadrant where cos is positive. So we get negative 4/5 plus 12/13, which is 65. Easier just to do on your calculator. Negative 4/5 plus 12 divided by 13. 8 on 65. Okay. So there, yes, that's got to be positive. In the fourth quadrant, that's got to be negative. Sine does, yeah. Okay, discrete variable x has a problem. P equals 0.1 for n trials where n is greater than 2. If the probability of obtaining at least 2 successes after n trials is at least 0.5, then the smallest possible value of n is. Okay, the probability of obtaining at least n has to be greater than 2. The probability of success is 0.1 for n trials, and n is greater than 2. The probability of obtaining at least 2 successes after n trials. Probability that x is greater than or equal to 2 is at least 0.05. The smallest possible value of n is. Okay, so we go from 2 to n with 0.1. So we say binom CDF from 2 to n trials, 0.1, and we want to find when it first goes above 0.5. So we get a table of values, and when does it go first go above a half? After 17. So n is 17. Okay, the maximum number of solutions for that, where k is a real number. Okay, so x log e negative x. Where are we? X natural log negative x. And then our other graph is 2x minus 1, 2x plus 1, 4x squared minus 1, and then 3x minus 1, 3x minus 1. Zoom in. Okay, the maximum number of, we know that we can say y3 is y2 of x, and we know minus k, and we know the k can only move it left and right. So there we've got 3 intersections. We can't have 4. The maximum number of solutions is 3. Yeah, 1, 1, 2, 3. You couldn't have 4 anyway. Because that all that does is translate it left and right. So we could have none, but the most is 3. Okay, this one here, which one is differentiable? So to be differentiable, the original function's got to be continuous. That's continuous. That's continuous, because if I put 0 in, they're both 0. 4, if I put 0 in, I get 1. Scrap that. If I put 0 into here, I get 1. It's continuous. 0 into that, I get 1. Okay, the derivative's got to be continuous. Well, that's going to be negative 1 and 1. That's going to be negative 1 and 1. That's going to be 2 and that's going to be 4x plus 4. If I put in 0, no. That's going to be 4. That's going to be, what would it be? 4x squared plus 4x plus 1. If I derive it, I get 8x plus 4. If I sub in 0, I get 4. So that's continuous for both. Okay, let A and B be two independent events from a sample space. The probability of A is P, the probability of B is P squared. The probability of A plus B equals 1. So P plus P squared is 1. What else do we know? The probability of A naught or B. So A naught is everything out here, or B is that. So it's 1 minus, it's the probability of, what's this one? What do we say? This is A, that's A, that's B. A naught, so it's 1 minus the probability of A only. 1 minus the probability of A only. What can we do here? Probability of A plus probability of B is 1. We need 1 minus the probability of A only. The probability of A plus the probability of B is 1. Two independent events. The probability of A intersects B is, because they're independent, multiply them, P cubed. So we know it's 1 minus that. So what am I thinking? 1 minus A only. So we know that whole thing is P. So this bit here is P minus P cubed, because we know in there is P cubed. So it's 1 minus P cubed, which is P cubed minus P plus 1. P plus 1, so it's D. So hopefully that makes sense. Probability of A naught, everything outside of A, or B is everything inside of B, is equal to 1 minus this, and we know that that whole thing is P. If we minus where they intersect, which is P cubed, we get this area here, and the outside is 1 minus that. 1, so P cubed, yep, so that's right. Okay, so hopefully I got those right. Don't know what to say about that one. I don't think it was ridiculously hard though, but maybe, I don't know, I never know. Best of luck, hope you did well guys, bye.